Okay, so a little bit more with the second derivative and increasing, decreasing, just kind of a summary. If we look at these graphs, at this point A, we know that the derivative is positive because f of x is increasing. And we know that the second derivative is positive because f of x is concave up. Okay, this graph is increasing but concave down. So f of x is increasing, which means the first derivative at A is positive. Because f of x is concave down at A, f double prime of A is negative. When my function is decreasing, this one is concave up, this is decreasing concave down. So f of x is decreasing and f of x is concave up. When it's decreasing, it means the first derivative at that point A is negative, and the second derivative at that point A is positive because it's concave up. And because f of x is decreasing for this fourth one at A, f prime of A is negative because it's concave down, the second derivative at A is negative. So that's kind of a summary of the four cases that you can have. So just to do a few problems with applying what we just learned with derivatives and second derivatives, it says which graph is f prime of A less than 0? Okay, so we're looking at the derivative being negative. F of A equals 0. Okay, so this is the y value, this is f. So the y value. And then f double prime of A, so again, this is the second derivative, is greater than 0. So this is positive. So we're saying at x equals A, f prime is negative. Okay, and that means that f is decreasing because the slope is negative. We're saying that the y value is 0. And we're saying that the second derivative is positive, which means f is concave up at that point. So we're looking for the a value, the y value of the a value to be 0. So that would be on the x-axis. So it's not this one and it's not this one because a is not, the y value is not 0 at A. But then we want our function to be decreasing and we want it to be concave up. So this is concave up, but this is not decreasing. This is neither increasing or decreasing. But this one, it is decreasing, it's going down, and it is concave up. The tangent line is below it. So this would be our answer. And then this one says, for which graphs is the slope decreasing? Okay, here's the key thing. The slope decreasing. The slope is decreasing where f double prime is negative, or when we're looking at f is concave down, whenever f double prime is negative. So if the slope is decreasing, that means the slope of the slope, which is the second derivative, would be negative, and f is concave down. So we're looking for graphs that are concave down. This one is concave down. That's concave up, concave up, concave up. This is concave down, and this is concave down. Okay. You can draw like the little tangent lines for the slope. And seeing this slope is getting more and more negative, so it's decreasing. This slope is getting less and, oh, sorry, that's this slope starts really high positive and then it's getting closer and closer to 0. So that's decreasing. And this slope starts out like really high positive, goes to 0, and then gets more and more negative. So it's decreasing. Okay, and then for another example, this one says the first and second derivatives of the function f of x have the given values in the table. Find the x coordinates of all the relative extreme, and then find the x coordinates of the inflection point. So we're looking at relative extreme, we're focusing on the first derivative. We know that the derivative has to be 0 and undefined, and then we know it also has to change sign. So if I look at here, from 0 to 3, the derivative is positive. At 3, it's 0, but it's staying positive. So that's that like plateau point. That is not a max or a min. Okay, at 5, it's just positive, so it's still increasing at 5. From 5 to 7, it's positive, but then at 7, it's 0, and then it changes to negative. So that means x equals 7 is a relative extrema. And sometimes it helps like to make your number line. And like this is 0. My derivative is negative, so it's decreasing. My derivative is positive, so it's increasing. And so this is a min. So x equals 7 would be a minimum, a relative min. So that's A. And then B says find the coordinates of the inflection point. So I'm going to look at where the second derivative is 0 and change the sign. So that's here when x is 3. So x equals 3 is an inflection point. It changes sign. And then x equals 5 is an inflection point because it was positive and then it changed to negative. And again, for inflection points, we're always looking at the second derivative. Okay, then one more example. It says, which graph has a negative first derivative for all? Negative first derivative means the slope is negative, so my function would be decreasing. So if I look which one is decreasing the entire time, and I'll give these numbers or letters. So that would be A. And then which graph has a negative second derivative? Okay, negative second derivative means we're looking for it to be concave down the entire time. So this does not have any concavity because it's a straight line. So there, the second derivative is 0. Same with this one. This one is concave up and concave down. So again, it's A. This one is concave down. It's curved down the whole time. So that's a few examples with derivatives and second derivatives.